Globe's Kanika niobium project in Malawi, Africa, and how niobium is powering the battery revolution. Here's our disclaimer. So why niobium? Niobium is number 3 out of the critical US list, and also important in the EU, Japan, Australia, and India. It's used in high-performance industries such as aerospace, defense, EVs, and clean energy. And it has a very fragile supply chain in that 85% is controlled by CBMM in Brazil. And significantly high prices, $61,000 per ton. And if we look at that compared to nickel, copper, cobalt, lithium, it's a significant value add. And prices are increasing significantly over the last 4 months. We can see this price increase. So if niobium is added to lithium-ion batteries, it makes the batteries greener, cheaper, cleaner, and cobalt-free. So it can enable fast charging within 10 minutes at lower operating temperatures. It has an increased range, so it increases the battery by 200% in terms of energy density, and it can withstand 10,000 charge cycles. And this is because of niobium's crystalline structure, which enables the high-speed transport of the ions, and it enables thermal stability. So in a conventional anode containing graphite, this has limitations when rapid charging occurs. Lithium builds up on the surface, and it can cause fires and increased short circuits, whereas niobium pentoxide has that stable structure after cycling, and therefore enables the ions to move into the anode, and it's as though it's moving into multiple parking spaces versus only one, and therefore enables faster charging, better battery safety, greater charge capacity, and longer lifespan. CBMM, the world's largest producer, currently has 1% of its revenue coming from the battery space, but it expects 25% of its revenue by 2030. And it has invested $18 million in Brazil's first industrial-scale niobium oxide plant, which is 3,000 tons of niobium oxide for the battery sector. So how is niobium used in batteries today? Skeletech Technologies is deploying niobium in its super battery and super capacitor. This is in the mining space. So in a real-world example, an electric mining truck goes down the ramp between 5 to 50 minutes, depending on the size of the mine, loads for 5 minutes, climbs back up the ramp, unloads for 5 minutes, and recharges in 90 seconds, and then goes back and completes the cycle. So Caterpillar and Komatsu already have electric mining trucks with niobium. Bolts in the UK have designed the Lotus EV, which is a prototype 35 kilowatt hour battery, 250 kilometer range, and recharges in 6 minutes using a 350K DC charger. So this contains niobium in both the anode and the cathode. In the anode, it is a niobium, tungsten, and silicon, which replaces the graphite. And in the cathode, it has nickel niobium as the coating, which reduces degradation, increases lifespan, and lowers first cycle capacity loss. Bolts are also in the industrial and robotics space. They use niobium in these warehouse robots, which are run 24/7, and they can be charged in less than 5 minutes, maximum uptime for the robots, and very low cost. And they can be used in all kinds of warehouses, such as ambient, refrigerator, freezer warehouses. Battery Streak are in the power tools space, and their batteries are niobium-based lithium-ion batteries, 3 times the cycle of conventional batteries. So even after 3,000 cycles, they're still maintaining 80% capacity. So this is a nanostructured titanium niobium oxide anode, and it's a major upgrade from the traditional graphite. And Stanley Black & Decker, one of the major tool manufacturers, are already using this. CBMM, together with Sojitz and Toshiba, have designed a prototype bus in Brazil, This can charge in under 10 minutes, so really important for the public transport industry, and this is expected to have commercial production by spring 2025. Novonix and CBMM have also worked together on a nickel-based cathode, which also enables durability, thermal stability, and cost efficiency. And Ekion, the leading provider of niobium-based batteries for the rail electrification industry, have developed a niobium battery which enables high energy density for faster acceleration and regenerative braking. It means fewer stops, less overhead lines, and a proper cost-effective zero-emission branch lines. And it's not just batteries. Japan's superconducting maglev train uses niobium tantalum magnets. So this means that it enables it to move over the rail without actually touching the rail. It can reach speeds of 600 kilometers an hour, and it operates at minus 270 degrees using liquid helium to cool the niobium titanium alloy magnets. And it enables superconductivity. So that is a continuous electric current, zero thermal energy loss, and really good, strong magnetic levitation. So it's a prime example of how niobium is going to be used in future transport systems. In the aerospace and defense industry, obviously the defense industry is growing significantly. This is because of the lightweight strength for extreme environments. Remember, the original use of niobium is ferroniobium, used in alloys. So niobium oxide, its high strength to weight ratio enables it to be used and reduce aircraft mass while still maintaining the structural integrity and performance. So this enables thermal stability at extreme temperatures. It's really good for jet engines, rocket nozzles, hypersonic systems, and because of its excellent weldability and precision fabrication, where tight tolerances are required in the defense industry, it's extremely important. And its lightweight resilience means that it can withstand the launch stresses, space exposure, and repeated landings. And lastly, the use of niobium in the camera lens industry is extremely important. Significant spend is happening in this industry. India have just spent $3.39 billion on smart cameras in their cities. South Korea have 160,000 new cameras in 2023. We have AI-enabled traffic systems like traffic monitoring, number plate recognition, all using these cameras. Medical imaging. This is the surgical tools, endoscopies, AI diagnostics use the cameras. And of course, the autonomous vehicle systems, which have the 360-degree cameras, all using niobium. So what does this all mean for Globe? So if we look at the mining industry, Fortescue invested in Williams Advanced Engineering. So we wonder, why did Fortescue invest in a Formula One racing team? It's because of their Formula E division, which uses CBMM, the biggest niobium producer in the world. It's E-Tech, which is now being repurposed for industrial mobility. So if we look at mining trucks over 90 tons, the global mining fleet requires 25 to 50,000 megawatt hours of energy storage. Niobium-based anodes require 5 kgs per kilowatt hour, with 25 to 50% of that being niobium oxide. That implies a 30 to 100,000 ton market for niobium oxide in mining trucks alone. Globe Metals and Mining has a JORC resource, 68 million tons of niobium oxide, with 3,000 tons of production capacity per year. That is only 3% of the global demand in the mining space by itself. So who is Globe? Globe ASX listed GBE. It has a Kanika niobium project in Malawi in Southern Africa. It will be the first niobium project into production in the last 50 years, and only the second vertically integrated niobium project in the world. Malawi is a democratic country, conflict-free, ex-Commonwealth, And we will build the mine and refinery all on site. So full beneficiation in country using HFSX in the refinery. It is a bottom quartile cost project. It's when you walk on the mine site, it's literally on the surface, low strip ratio, free dig operation. Fully JORC compliant resource, 68.3 million tons, long life mine over 27 years, and fully scalable. Fully permitted, mining license, mine development agreement, environmental, all in place, feasibility study complete, or with really good project economics. And we have already secured 50% of our funding for phase 1, which is 46 million to build a small phase of, which is 300 tons of niobium oxide per year, costing 46 million US. A part of that funding is EcoBank, which is senior debt for 15 million US, and the RDC of South Africa, Industrial Development Corporation of South Africa, for 10 million. And we are currently working on the remaining 46% in strategic equity. Following on from that, once we have obtained that, it is 18 months until we can, 18-month construction window until we can produce the first high purity niobium oxide. This is 99.99% niobium oxide, and we also have tantalum. So niobium almost always comes with tantalum from a geological point of view. So out of the 300 tons of niobium, we also have approximately 15 tons of tantalum. So this is a phased de-risked project, which means a small amount of capex to begin with and quick to produce. And we already have 100% of our production for phase 1 covered by offtakes. Number 1 being A. Phillips in Europe, which is the supplier of master alloys. Number 2 being Mist Trading in Singapore, which is an international trading house. And number 3 being Near Performance Materials, which was discussed by Walu in the last discussion, who produce high purity metal products for the defense, aerospace, and EV industry. So in summary, Globe's niobium oxide product meets the specialty metal sector, the battery sector, and the emerging energy transition market, and is non-radioactive as an oxide. Thank you.